Okay, so today we are going to learn about creating, solving, and graphing inequalities. Oh, little pointer things can be crazy again today. Okay, so an inequality is a statement that compares two expressions that are not strictly equal by using one of the following signs. And you guys have probably seen these signs before. We have the less than sign, the less than or equal to sign, the greater than sign, and the greater than or equal to sign. And so we solve our inequalities pretty much like we do an equation, except we have these signs in between. And instead of a direct solution, we have what's called a solution set as our answer. So here we have our first one, and this is a one-step inequality. So we have 2x is greater than or equal to 6. And so since this is multiplication, we would just divide on both sides. And I have x is greater than or equal to 3. Okay, so what that's telling me is that if it's greater than or equal to 3, 3 is part of my solution set, and then anything that's greater than that. So I would graph that. And here's positive 3. I'll just put us a pretty little graph on there. Okay, so we're going to circle it. Since there's an or equal to, it means it's part of it. So I would shade that, and then I would shade everything that is greater. And clear that off of there. Okay, so we also have this one. It's a one step as well. And goodness gracious. Okay, so this is division. So we would multiply both sides by 5. These cancel, and we get A is less than 1 times 5, which is 5. So in this one, 5 is not part of our solution set, but anything less than 5 is, and so I can graph it. There's the bell. And so we'll go all the way to positive 5. Now this time when I circle it, I don't shade it in because 5 is not part of the solution set, but I'm going to shade everything that's less than that. And you can see how pretty that looks. Okay. Okay, here we have a two-step inequality. And so once again, it's like our two-step equation, but we have a different sign, and of course we graph our solution set. So we're going to get rid of our constant term first. So this was adding 7. We're just going to subtract 7 on both sides, and I would have 5x is greater than or equal to negative 5. Because 2 minus 7 is negative 5. And then I would divide by 5 on both sides. And I get x is greater than or equal to negative 1. Okay, so then I'm going to graph that. So here's 0, and here's negative 1. I'm going to circle it and shade it because it has an or equal to, meaning it's part of the solution set. And then oh my God. Then I'm going to shade all the way, and I hope your graph looks prettier than mine, because that looks pretty wild, I will admit. Okay, and on this one, we have the distributive property. And so we have to do that part first. And so I will multiply my 5 by my z and by my 6. So this gives me 5z plus 30 is less than or equal to 40. Okay, then I'm going to subtract 30 on both sides. 5z is less than or equal to 10, divide by 5, and z is less than or equal to positive 2. And then we can graph that one as well.